Past research has shown the importance of a flow and move approach during interior fire suppression for the survivability of trapped occupants and the safety of operating firefighters. This approach allows us to take advantage of maximum surface cooling while utilizing a moderate amount of air entrainment. Let's begin by taking a look at air entrainment values with different stream types and application patterns. Suppose that you are positioned at the start of a hallway holding a straight or a solid stream aimed downrange in a fixed position with no manipulation. In this case, you are entraining about 1,000 to 2,000 cubic feet per minute of air into the stream. As soon as you start to manipulate that stream into an O pattern, you increase the air entrain to approximately 4,000 to 6,000 CFM. This will occur regardless of the type of pattern chosen and is more dependent on the speed of the application. If we now change from a straight or solid stream to a fog stream, the air entrainment increases dramatically. For example, a narrow fog stream held fixed entrained approximately 10,000 CFM of air. If we now manipulate that fog stream into an O pattern, we can expect to see the air entrainment in excess of 15,000 CFM. This magnitude of air entrained with fog streams can be comparable to that of a positive pressure fan. It is important to understand that these values are similar regardless of whether you choose a straight stream from a combination nozzle or a solid stream from a smoothbore nozzle. Air entrainment in hose streams is less dependent on the flow and nozzle pressure and more dependent on the movement of the stream and the speed of the pattern chosen. As we have learned through the suppression studies, straight or solid streams maintain large enough droplets to ensure the maximum amount of heat is absorbed and the most amount of surfaces are cooled. In contrast, utilizing a fog stream may be effective at absorbing heat from the gas layer, but the size of the droplets do not allow for sufficient surface cooling. With minimal surface cooling and maximal air entrainment, fog patterns are not an effective stream choice for initial knockdown of a post-flashover ventilation-limited fire. One successful means of extinguishment is to employ an O pattern on the advance to a fire compartment. During a flow and move advance, this pattern can essentially seal off the space ahead of the advancing hose line, taking advantage of air entrainment to draw fresh air in behind. This will prevent the products of combustion from coming back over the firefighters while allowing the higher temperature, higher pressure gases behind the firefighters to ventilate out of the structure. Venting of the gases behind the advancing crew will improve survivability for trapped occupants and visibility for searching firefighters. Applying an O pattern on the approach to a fire compartment will ensure that the surfaces are cool and will limit the thermal exposure to the nozzle team on the advance. Water applied in the hallway is simply used to help the nozzle team get to the fire compartment safely and begin to take control of the space. However, water applied in the hallway will not be able to map surfaces inside of the compartments. Once the nozzle team has an idea of the location of the fire, attempts should be made to get water into the compartments as early as possible. This could include deflecting the hose stream off of the door frame of the fire compartment for early water application onto the seat of the fire. As the nozzle team reaches the threshold of the compartment, the same approach to that of exterior water should be taken. An initial steep angle will coat all surfaces in the compartment. Once the fire is darkened down, the stream can then be brought lower onto the remaining burning fuels. After the fire is extinguished, the nozzle team should employ hydraulic ventilation out of any available opening to aid in smoke removal from the structure.